steering system. Whatever the steering system we are going to look forward, the objective of any steering system should be that the driver effort should be lowered to achieve effective turning of wheel on the road. Okay, this is what, and this is possible with power steering system compared with the manual steering system which we have seen, that is ball recirculation gear steering system, rack and pinion gear steering system. So the main objective of this power steering system, the power steering system lowers, it minimizes the effort needed by the driver to steer and control their cars, which improves the driving efficiency or driving experience. So here we have two kinds of power steering system. One is hydraulic power system and another one is electric power system. Most of the cars still today they are using hydraulic power steering system, okay, to create force necessary to move the wheels. And electric power steering system, they are used in sport vehicles, they are used in modern cars to achieve better driving experience or efficiency. Okay, two power systems in presently which are widely used. One is hydraulic power steering system. Another one is electric power steering system. Whatever the steering system, the objective of the steering system, it should lower the effort needed by the driver to steer and control their cars to improve the driving efficiency or driving efficiency. Okay, two types of power steering system we have in presence which are used in most of the modern automobiles. One is hydraulic power steering system, electric power steering system. In an automotive steering system with engine power, it is used to improve the evening of torque. The torque plays very, very important. See, whether it is a hydraulic power system or electric power system, we are not going to use any additional external power. Some portion of the engine power is used for driving the steering system. Now we should discuss about the hydraulic power steering system. What is this hydraulic power? This hydraulic power system, it actually consists of a hydraulic cylinder which is filled with the lubricating oil or some kind of oil which will have more viscosity. Okay, a hydraulic or electronic actuators add controlled energy to the steering mechanism so that the driver can provide less effort to turn the steering wheels when driving at typical speeds. Okay, so once when the driver is driving the vehicle at slow speeds, at modern speeds, turning will be very easy. But once if you want to steer the vehicle, if you want to turn the vehicle, once when the vehicle is at higher speed, that time the effort needed by the driver, it is very, very not only effective steering, it also the time sense of the driver is needed. Okay, ultimately the objective should be to whether going on higher speed or going on slow speed or going on modern speed, the driver should need minimum effort to steer the vehicle, to turn the vehicle according to direction in which the driver is intended to drive. Okay, and this is where hydraulic or electronic actuators will support will support. Particularly, this is very effective once when the turning is taking place by the driver at higher engine speeds. This is very important. Okay, this point should be remembered. Okay, again I will repeat, the steering or turning the wheel, it is not much this thing, what is this, it needs more this thing effort once when the vehicle is moving at low speed or medium speed or moderate speed. But effort needed is very effective by the driver once when the driver intended to take a turn of the vehicle, once when the engine or automobile is moving at higher speeds. And this is effectively done with this hydraulic power steering system. Okay, and another important parameter of this hydraulic power system is that if there is a failure of hydraulic steering system, okay, there is another this thing is also provision is also provided in the system. If due to some regions the hydraulic power steering system there is a small kind of failure, by then there is a manual steering system will be there, and that is used to take the turn of the vehicle. This is possible in case of hydraulic, but once before the vehicle is taken out for drive, we should check it whether required amount, there is a sensor will be there. It shows the required amount of oil in the hydraulic cylinder, it is there or what, that should be checked. Okay, it should maintain a particular level in the cylinder. The oil or the lubricating oil, it should be filled in the cylinder to a minimum level. Until that level, the hydraulic steering system will work effectively. If the fluid level comes below that, there is a chance of failure of entire hydraulic steering system. By then, the manual system will support, okay, for taking the wheel to turn. But whatever the case may be, the sensor should be keep on frequently checked whether the availability of the oil in the cylinder, it is there up to the mark. It is there up to the mark. And as far as this hydraulic steering system, certain points again we should note. Hydraulic steering system, it reduces the steering effort of the vehicle by using hydraulic pressure to assist the turning of wheels. Okay, here as I said, the hydraulic cylinder, it is filled with the oil, any oil which will have more viscosity, and that hydraulic pressure is used for steering effort to turn the wheels on the road. Okay, the steering booster, the steering system consists of the following basic elements. One is steer torque detector, controlled pressure distributor case, hydraulic booster pump, tank with a working, tank is nothing but cylinder, tank with a working liquid, connection, whose connections. I was telling the hydraulic fluid, the working fluid, it should be a oil or lubricating oil or any oil which will have more viscosity than water. Okay, even some cases mineral oil also it is used as a hydraulic fluid in hydraulic power steering system. See, this is the schematic diagram of hydraulic power steering system. Just you go through and I will explain how it works. Or even if you have 1 or 2 minutes, a small line diagram if you want to draw, you can draw it. See, starting from, let us start with the cursor. I will bring it to steering wheel. Okay, and the I'm bringing the cursor. This is the power steering pump, and it is connected to the cylinder with the help of a hose pipe. Okay, then here we'll have a, I'm getting the cursor nearer to rotary control valve. Okay, and this is one tie rod, and left also you can see one more tie, two tie rod, because two wheels will be there on the front of the vehicle. Okay, now I am bringing the cursor to, this is the rack gear, this is pinion gear. Cursor is there, this is pinion gear. Okay, this rack and pinion gear will operate by using the hydraulic pressure, and the hydraulic pressure is created by a system called power steering pump. Okay, and piston always travels. This is called the, I will show here. This is the piston. This piston always travels against the direction of hydraulic pressure. Okay, so here you can find two. I will bring the cursor. Two fluid lines you can find. One is high pressure fluid line, another one is low pressure fluid line. Okay, once when the hydraulic pressure is created, by then the piston moves opposite to the high pressure line, then the pinion gear, the teeth of the pinion gear will rotate, will move on the teeth which are provided on the outer surface of the rack. Okay, once when the piston completes its travel in one direction, again the pressure falls, it moves in opposite direction, by then again the pressure is created, again it moves, so that the steering effort will be achieved to turn the front wheels according to the intention of the driver, in which the turning he is expected to turn. See, just you see. Okay, this is the schematic diagram of hydraulic power steering. Okay, you can see steering wheel, you can see the front two wheels. Okay, you can see the power steering pump, which produces the required hydraulic power, hydraulic pressure, which requires the hydraulic pressure. And this pump is connected to the cylinder through the hose pipe, and the control valve controls the amount of fluid inducted into the cylinder according to the requirement of steering. Okay, and it is pinion and rack gear system is there. Okay, hydraulic piston will be there. Once when the high pressure is created by the pump, this piston will move against the direction of high pressure. By then the steering effort will be achieved for turning the wheels on the road. Okay, this is how, and through this the effort needed by the driver, it is minimized compared to the effort needed by other two manual steering system. Which are the other two manual steering system? One is ball recirculating steering system. Another one is rack and pinion steering system. Okay, so this is how it operates. Again, what the same I have shown in this thing. This right side you can see it is a pump, And this left side, you can see this is the hydraulic steering system. Okay, this pump, it is showed separately to the right, and the left, the figure which you have seen in the previous case. But here the gears are not seen. In the previous case, you can see the gears properly. The teeth of pinion will move on the outside surface of the teeth on the rack, and pinion and rack gears are housed in the steering gearbox. This is the, I will bring the cursor here, you can see. Okay, and this is the control valve, which is in the previous figure also you can see. This is the pump which creates the required pressure, and this supplies high pressure fluid to the cylinder. This is how it works. Now, I hope you understood the working principle of hydraulic power system. Okay, so I will repeat in brief how the hydraulic power system, this thing it works. Okay, it is having a cylinder in which it is filled with hydraulic fluid, which is nothing but an oil, mineral oil or lubricating oil, any oil which will have more viscosity. Okay, the pump will be there. It provides the required pressure oil to the cylinder, which is needed to give the effort to the steering system. This minimizes the driver's effort for turning the wheels. Okay, it consists of a gearbox, whereas the pinion and rack gears are housed. Okay, and there is a hydraulic pump will be there. It moves against the pressure for getting the wheels to turn with minimum driver's effort. That is the working principle of hydraulic power steering system. And now one more steering system we are going to discuss here. This is electric power steering system. Okay, so both will work under the same principle, whereas here the hydraulic systems are absent. Hydraulic system in the sense the pump, cylinder and control valve, the complete system, it is absent. Otherwise other things are similar. The electric power steering system use electric motors instead of hydraulic components. Electric power steering systems use electric motors to provide the assistance instead of hydraulic systems. What are hydraulic systems? The pump, cylinder, the fluid and the control valve and the piston. Complete that this system is absent in this. Electric power steering systems use electric motors to provide assistance instead of hydraulic systems. As with this hydraulic system, the electric motor, it replaces the complete hydraulic system. Here, the electric motor, it replaces the complete hydraulic system. What is the hydraulic system? It is the hydraulic fluid, the hydraulic cylinder, the hydraulic piston, then what is this? The complete pump, which is required for pumping the high pressure fluid to the cylinder for steering. Here in electric power steering system, that complete hydraulic components are replaced by a motor. Other working principles are similar as you see. Electrically assisted steering system, also known as electric power steering system. Here, whatever the hydraulic system used to do in previous case, the electric motor will provide the required turning power to the driver. Okay, in this electronic power steering system, the advantage over hydraulic system is that if the engine fails, still the steering assistance will be provided. But in previous case also we have seen, if the hydraulic system fails, the manual steering system can be used. But here the difference is that if the electronic power steering system fails, okay, still the steering assistance is provided for a certain duration of operation of the vehicle. This is the difference between that. But disadvantage can also be a disadvantage. Okay, particularly when the engine is shut down, the steering assist will be continued, which is a loss of energy to the system. Loss of energy to the system. Again, I will repeat the difference between electric power steering system and hydraulic power system. In electric power system, the hydraulic complete system is absent. Whatever the work used to done by hydraulic system, it is done with the electric system. This electric motor replaces complete hydraulic components. Okay, and the advantage associated with this electric power system compared with hydraulic system, if there is a failure of electric power system, still the steering assistance will be continued, steering support will be continued to the driver for a certain duration of its operation. And even in previous case also it is there, but the previous case there is slight difference. If the hydraulic power system fails, what is going to happen? A manual steering system can be used. But here no need to use the manual steering system. If there is a failure of electric power system, still for certain duration of operation, the assistance of this hydraulic energy will be made available to the driver for steering effort. Okay, this is the advantage with this. And now you can see, this is how the electric power steering system. Just if you have 1 minute, 2 minutes time, have a line that already I circulated the complete listing to you, but always practicing will support you a lot. Okay, this is the motor. This is, I'll show you curve. This is motor. This is the steering wheel. This is the gear system. Here also it is rack and pinion gears are used. Okay, and because of the resistance created during the magnetic field, the steering energy is given to the driver for steering the wheel, as well as with the less effort of the driver, these wheels can be taken a turn according to the intention of driver in which he is intended to take the time. And as far as the cost of this system is concerned, it is comparatively cheaper than the hydraulic system, whereas we have the costlier components like the cylinder, the pump and other things which are absent in this electric power system. And another advantage of this electric power steering system is that if there is a failure in electric power system during the vehicle is running, for certain duration of operation of the vehicle, the power of this electric this thing is provided to the driver for steering purpose, which is not possible in case of hydraulic. In case of hydraulic, if there is a failure of hydraulic system, manual system is operated for steering the wheels, for turning the wheels. Okay, and this is comparatively cheaper compared with hydraulic power system. And these the hydraulic power system, the applications, if you look into, they're used in majority of the vehicles, 80% of the vehicles. Nowadays, electric power steering system, they are more widely used in modern vehicles where efficiency is important. Okay, and this provide better efficiency compared to hydraulic power system. Okay, this is used in modern vehicles, preferably in sport vehicles. This electric power steering system, it is used. Okay, did you understand? Right. Now, some of the important this thing already which I told, the power steering system will, a hydraulic power system will have a pump which is not there in case of electric power system. And the pumps used in hydraulic power system are 4 different types of pumps. One is roller pump, vane pump, slipper pump, and gear pump, out of which the vane pump is mainly used in majority of hydraulic power steering systems. Note down, vane pump, it is mainly used in maximum automobiles in hydraulic power system. Okay, others are also used, but majority of the vehicles will use, the vehicles which are using this hydraulic power system, vane pumps are used. Now, with this, I hope we have done with the steering system, and we have done with the different kinds of, we described what is steering system and what are the major functions of steering system, why steering system is necessary, what are the major functions of steering system, and what are the different types of, what is the role of steering gear, and what are the different types of steering systems. 3 main steering systems are used in practice. One is ball recirculating steering system, rack and pinion gear steering system, power steering systems. And again, in power steering system, 2 steering systems are used. One is hydraulic power steering system, another one is electric power steering system. Both the objective of both this power steering system, whether it is a hydraulic or this thing, what is this, electric power system or any steering system, the effectiveness of steering system is only noticed when the steering system lowers the effort of the driver for steering the wheels, for turning the front wheels while taking a turn. And this hydraulic power system and electric power system, comparatively they by using this power steering system, these power system lowers the effort required by the driver for turning the wheel on the roads. And we discussed what are the operating principles of this. And now we should start with what is another important parameter in steering system. Steering geometry, it plays very, very important role. Steering geometry, it is related to road wheels. It is related to road wheels. Okay, as far as the steering geometry is concerned, okay, this steering geometry, it refers to angular relationship between suspension and steering parts of the front wheels and the road surface. Okay, the steering geometry we are going to discuss in the geometry. The relationship, as far as the angular relationships are concerned, between suspension system and the steering. What are the steering parts? The mechanical linkages, tie rods, tow rods, okay, and the front wheels and the road surface. The angular relationship between front wheels and the road surface. The angular relationships between the steering parts and the wheels, and the angular relationship between suspension and steering parts. These are the things which we are going to discuss in steering geometry. The alignment of the above said angles will affect the complete performance of the steering system. Complete performance of the steering system. There are 5 steering geometry we are going to discuss in detail. We are going to discuss in detail 5 steering geometry in this. What are the geometry? Again, I'm coming back. The angular relationship between suspension and steering parts, and between front wheels and the road surface, between steering parts and the front wheels, between suspension and steering parts and the front wheels. Here we are going to discuss mainly 5 steering geometry angles. One is camber, or it is also called camber angle. Another one is called caster, or this is also called caster angle. Another one is called kingpin inclination. Another one is called toe in and toe out on turns. These are the important angular relationships which we are going to discuss in this steering geometry. And before that, the wheel alignment, we should check it. If the wheel alignment is good, then this angular relationship will support in influencing the better steering effort, better steering efficiency, better suspension efficiency, better suspension effort. Okay, suspension we are going to discuss after this. Okay, wheel alignment plays very important role as far as the steering system is concerned, as far as the suspension system is concerned, as far as the angular relationship between the road wheels and the road surface, road wheels and the steering components, road wheels, steering components, and the suspension system. These angular relationship will support, provided the wheel must have aligned properly, effectively. Okay, what are the major advantages we are going to have with effective wheel alignment? Okay, generally after 2 or 3 months of running of your automobile, you are going to check for wheel alignment. You must have, those who are having car or bus, you must have seen, you will be frequently visiting the wheel alignment compartment where the wheel of your car or any automobile will be aligned. What are the advantages we are going to have with effective wheel alignment? The wheel alignment must be properly aligned so that if the wheels are properly and effectively aligned, we can have the directional stability during straight ahead position. Okay, very important. Once when the vehicle is moving on straight line, directional stability, it is very important. You must have seen whenever you are driving your car in a straight road without taking any turn, just you are keeping your hand on the steering wheel. You are not using the steering wheel. You are not rotating the steering wheel, but you are holding your hand on the steering wheel to see that the directional stability, particularly once when the wheel is running straight ahead position. And this directional stability is possible only with proper wheel alignment. If the wheels are not aligned properly, okay, if you are driving a car on the straight ahead position, you feel regularly to slightly revolve the steering wheel. You feel to do it because of the improper wheel alignment. If the proper wheel alignment is there, just you are holding your hands on the wheel, and there will be definitely directional stability will be there once when the car is taking a straight ahead position. Okay, and another advantage of proper wheel alignment is that perfect rolling conditions can be achieved during steering. What do you mean by perfect rolling condition? Whatever the turn, whatever the angular turn you expect the wheel to take after applying your effort on the steering wheel, it is possible if the wheels are properly aligned. If wheels are not properly aligned, then what happens? Okay, you keep on slightly keep on rotating until you expect the turn as taken by the wheel. Okay, if the wheels are properly aligned, perfect turn is possible by the road wheels once when the driver turns the steering wheel. Okay, this is possible by proper wheel alignment. And another recovery of completing the turn. See, I was telling in the previous section today itself, the steering system should have a self-rightening effect. What do you mean by self-rightening effect? If you are driving a car, okay, if you stop rotating the steering wheel, okay, the steering wheel should come to its original position and the wheel should run the straight ahead position. The wheel should take the straight ahead position then. What is then? After taking the wheel turn. Okay, this is called self-rightening effort. Okay, and this is possible if the wheels are properly aligned. If the wheels are properly aligned. Okay, now just we'll see this, and this onwards we'll discuss from the next class. Just I will tell about what is camber. Okay, you can see the figure. The figure is also there to the right. Okay, so this is the wheel. You can see this is the wheel. This is the wheel. Okay, and this is the kingpin axis, which you can see in the previous figure. Okay, now what is this camber? Camber angle it is shown. Camber angle it is shown. I will bring the cursor here. This is the camber angle. This camber angle it is defined. This camber angle is the angle between the vertical line of the wheel. It is camber angle. This is the angle between vertical line and center line of the tire. And center line of the tire when viewed from the front of the vehicle. C, it is C. This is the camber angle. I am bringing again the cursor here. I hope you are seeing it. Okay, camber angle, you can see it is the angle between vertical line and center line of the tire. Center line of the tire when viewed from the front of the vehicle. When viewed from front of the vehicle. Okay, so we have two camber angles. One is positive camber angle and another one is negative camber angle. Okay, the positive camber angle, it is that angle when this angle is shown outwards. But whatever the camber angle it is shown, it is negative. Okay. And this happens once when the wheels are further apart at the top than the bottom. Okay. And negative camber angle it is defined. This negative camber angle will be achieved when the wheels are further apart at bottom from than the top. Okay. See, always whether it is a negative camber or positive camber, so have a better wear characteristics. The camber angle should not exceed more than 2 degrees. Okay, whether it is a positive camber or negative camber angle, you can say camber or you can say camber angle. Both are one and same. So as to have a better wear characteristics, whether it is a positive camber or whether it is a negative camber, the camber angle should not be more than 2 degrees so that the wear characteristics are better. Where the wear is going to expect? The wear is going to expect between the road surface and the tire of the wheel. Here you can expect this thing. I hope